In an earlier video, we looked at crystallization in a ternary phase diagram. Now we're going to take a look at melting, and we'll look at the same compositions we looked at before. So we'll start out with this composition A in this diagram from John Winter's textbook. What if we have a rock that's made of anorthite plus forsterite plus diopside and it falls here in this diagram? How would melting occur? Well, melting will always begin at this lowest temperature, the eutectic temperature, first, where the minerals will melt together in eutectic proportions as defined by the position of that eutectic. That eutectic is very low in forsterite content, so northite and diopside are going to precipitate out, or excuse me, will melt out at a much faster rate than forsterite. But which will be the first mineral to disappear? Well, the way we would find that out is really the reverse of what we've done before. Eventually, we have to get into the forsterite plus liquid fields. We know that even though all three minerals are present, once we start heating the system up, forsterite will be the last mineral to form, last mineral to melt. And how would we figure out what will be second? Well, as we melt, we're going to have to move towards the forsterite apex. So it's the opposite of what happened with crystallization. And if we're going to move towards the forsterite apex, towards something like A, we would have to do so from a position that is sitting on the diopside plus forsterite cotectic. And the only way we can be on the diopside plus forsterite cotectic is if we get rid of anorthite first. So anorthite will melt out. Once anorthite is gone, then we'll just work our way backwards from the way the arrows are indicated. The arrows are pointing down temperature. We would increase in temperature as the liquid would migrate, moving away from anorthite. As we begin to melt, it's going to move towards this point here. Once we reach this point here, the last little bit of diopside is going to melt out. Now there's only forsterite left, and as we add forsterite into the liquid by melting out the crystalline forsterite, then the liquid will become more forsterite rich. It's going to move towards the forsterite apex, moving towards A, and by the time the liquid composition reaches A, then there's hardly any liquid left, just an infinitesimal amount. So as we reach the temperature 1700 degrees, then the last little bit of solid material is consumed. I might have said that backwards. We're losing solid material, not liquid material. So we run out of solids. Now the system is entirely liquid. And if we increase the temperature further, relative to this diagram, there won't be any positional change. A will simply get hotter and it would move vertically up out of the plane away from this contoured surface that represents the composition and temperatures of systems that are in equilibrium with forsterite and liquid. Let's take the other three compositions as examples. Let's take this fellow here. If it is made mostly of anorthite, looks like it's almost 80% anorthite, with the rest being diopside plus forsterite. Melting will start here at 1270. Which of diopside and forsterite will disappear first? We know anorthite has to melt last because it's sitting here in the anorthite plus liquid field. We'll draw this line. We have to get rid of diopside first so we can climb up this cotectic here, the anorthite plus forsterite cotectic. So the system will sit here until diopside is consumed, and then the liquid will begin migrating up this point here until we reach here. At this point, the last little bit of crystalline forsterite is gone, and there's only anorthite left. With any further melting, the liquid will be enriched in anorthite, migrating towards the anorthite apex here, and it will continue melting up a little bit past 1400 degrees. And once we reach about 1410, 1420 or so, then that's when the last little bit of crystalline material will be gone and we'll be left with a liquid of this composition. Any further heat that is added will just make that liquid hotter, and it would migrate vertically out of the plane towards us. How about this composition here? Again, all melts begin at the eutectic at 1270, so we just have solid below 1270 degrees. The first melts that we will get will have this eutectic composition, very poor in forsterite. We need to eventually be in the forsterite plus liquid field. So if we're going to move it towards forstrite through that point, we have to do so from this anorthite plus forstrite eutectic here. So that means, again, just like this fellow here, diopside will disappear first. We'll have a anorthite plus forstrite that will be melting out. So the liquid starts here in composition. And once diopside is gone, then the liquid will begin migrating up this curve here, the eutectic, and once it reaches this point here, then the last little bit of anorthite is gone. Now the liquid will be enriched in forstrite. That's the last crystal that remains. And as we add forstrite to the liquid, then the liquid will migrate in this direction up to a point where the temperature is just below 1500 degrees. And that's when the last little bit of forstrite is gone and the system is completely liquid. And again, we'll just take this composition here to finish up. As always, we start with liquids of this composition here at the eutectic at 1270. So we'll heat up the rock until the first little bit of liquid is produced at 1270. The liquid will have this composition. And the first mineral to be consumed, it looks like it'll be forstrite because we have to migrate up this anorthite plus diopside eutectic. We can only do that when forstrite is gone. So we'll sit here at 1270 until all forstrite is consumed. We'll have the temperature increase until we reach this point here. That's when the last little bit of anorthite disappears, and then when anorthite is gone, now the liquid will have only diopside crystals left, and the liquid will migrate towards diopside, but it's not going to get all the way there because we don't have a pure diopside system. Otherwise, we wouldn't be at the eutectic in the first place. The liquid will migrate towards diopside until it gets to this point here, and once it reaches that bulk composition, let's get this line out of the way, once the liquid migrates and hits that point there, at a little below 1300 degrees, that's when the last little bit of diopside crystals are gone, they've been melted out, and the system is completely liquid. So that is the case of melting in the ternary eutectic anorthite forstrite diopside.